Good day to everyone. Welcome to Acadsystems free online lesson for today. My name is Muhammad Nasrul Shafwan and I am an application engineer for Acadsystems. For our sharing today, we will be going through the Autodesk Product Design and Manufacturing Collection or the Autodesk PDMC. And our topics for today is the Weldment tools with Autodesk Inventor. First of all, why should we use the Inventor? Is because we can predict costs, we can create more design, and we can also improve product performance. Okay, before I forgot, I will record our session for today. Right. We will be going through these benefits while we do our presentation. And thank you for coming to today's free online lesson, Ms. Chuin and also Mr. Hanan Bahrain. So first of all, our weldment tools. We need to know how to create our weldment tools. So basically this is the first step, and we will be going through this in the Inventor, right? And also we will, without further ado, we will proceed on the demonstration. Right. Before we start, I already have created the link for our data set, right? You can see in the screen right now. And also I will put it in the chat. And you can open it and download the data set while we do this free online lesson together, right? So first of all, to start our Inventor assembly, we need to create our project. So for today, I already created my project, which is the Weldment project. And to start, okay, we will start with the assembly. Okay, first we click on the assembly. So right now, this is a normal assembly. And then we can just right click and place component. Okay, so the component that we will be using right now, or we will be using today, is first we will start by using the plate inventor part. Okay, just click and open. Right, let me change to the home view first. Okay, now I just left click to place our component. Okay, for now I am going to hide the visibility of the work plane. Just go to the model here and just right click and click on the visibility, or you can also click alternate V. So we have our model here. Okay, to make it look a lot better, so we can go to view and then change the visual style to shaded with edges. Now we can see the shaded part here. Okay, as you can see here right now, we don't have any weldment tools. So this is because we are currently inside the normal assembly. So to change that, we can just click on the environment and then click on the convert to weldment. So what happens is it will prompt a window here that say this assembly will be converted into a weldment. And then just click yes. Right now, you can select the standard. Either you want to use the ANCI or DIN. Okay, so for today, we will be using the NC, and also you can change the type of welding or weld bed material. So for today, we will be using aluminium 6061 welded. And this is for the bill of material structure. Either you want it to be normal or inseparable, which is it will not be separate from this model. And click OK. And now you will notice the changes in your workspace. So you will have one more tools here, which is the weld tools. And the welding tools is break into three major parts. Okay, you have the preparation, the weld, and also the machining. First, we start with the preparation. Okay, right now, when we click on the preparation, this is where we want to prepare our model before we weld. Because on some parts, which is the metal, we have to grind and sand it. Okay, let's say we want to chamfer this side. So just click on chamfer and select these edges. Okay, now our distance here is 2 mm. So I want to change it to 3. Okay, you will notice that this is cut off too much. So we will just proceed with 2. And once we're done, just click apply and close. Please wait a minute. Right. So when we create our preparation, and once we're done, we click on return. So for our preparation, it will not be altering any of our model. So in order to know that, we just open our inventor part here. Okay. And you can see that there is no changes done to our plate here. So, and if let's say you go to the drawing, this will not also be shown. So this is only the preparation for our weld. Okay, now we just click on the weld tools here. Okay, this is weld. For Inventor, you have two types of welding here. For simulation, we have the fillet weld and also the groove weld. Thank you for coming, Mr. Shahir Zuni. Okay, now we click on the fillet tools here. So for welding in Inventor, you can do the welding whether it is 1G, 2G, 3G, 4G, and also 5G. For this part here, okay, we have 1 and 2. So for 1, this is our first phase, which is the chamfer that we created before. Just select this phase. And then the second one is this plate phase. Click that here. And then for this one is the size. If let's say I put 10, you cannot see anything because that's probably your size of your weld bit is too big. And if let's say we put it to 5, also we cannot see. And if we put it to 2.5, okay, now you can see this part here. This is the green triangle here is the preview of our weld here. So we put it 2.9. Okay, and this is our leg 1 and also leg 2. So we just use the leg 1, and we can also create the contour. Okay, for the contour, we have 3 types, either flat, convex, and also concave. But why does it not show? Is because when you change to concave or convex, okay, when your size is not proper, and also the situation, let's say in this case, this vertical plate and also this horizontal plate cannot create a concave and convex weld. So for now, we just use the flat, So 2.9, 2.8. And then for the intermittency, so this one here, we have two blank column that we need to fill in. Okay, the first one is length, and the second one is the distance between each length. So to make it more understandable, we first let's say we put the value as 1, and then the distance is 2. And you can see, instead of we weld from one end to another, we create 1, 2, 3, 4, and 5. So we have 5 intermittent weld bit. And if let's say you put it empty, it will create from end to end. And also we have this extend here, where if let's say you want to specify where you want to start the weld. Okay, let's say for this one I want to start. Okay, so why does this one here is the one that start? Because you can see the arrow, it goes from this right hand side to left hand side. So we can flip the direction by clicking this point here. Flip direction. Just click this, and then we can, let's say we start from 2. You will see when we click apply, this weld will start from 2 mm here. And also if you want to make changes, you don't have to delete this. You can just go to the model here, click and bits, and you double click to the fillet weld here, and you can edit this one. Oops, for the start offset, just empty, and just use all instead. Okay, and now it will automatically update it. And you can see here we have the end fill. When we create our weld, this end fill automatically will automatically be created by the end of the welding. Right, so that one is on the fillet welding. Okay, next we click on the weld again. We have next is the groove weld. So for groove weld, this is a little bit different from the fillet weld. So for this one, you just have to select phase 1 and then rotate, change to phase 2. And then the next one, this is important, where you have to select the fill direction. As you can see, we have the dotted yellow line, and for my groove weld here, I want it go from left to right or right to left. So which is it move horizontally. So just click on these edges. So it will based on this direction. Click apply and close. Now we are able to create the groove weld. Right. So in welding, usually you will have to add the symbol. So for the symbol, you can manually add this. Okay, let's say I want to add this groove here. Right. So when you click here, you can select your weld symbol. So for this case, we are welding on the top side here. So this one is empty. So we start on the top, which is our square groove weld. So this is square and also groove. And also if let's say you use the brazing technique, you can just turn it on, and then so that you can communicate better with your colleague or your subordinates. And for this one is the length of your leg, okay, and also the information. So for this one, I just want to make the symbol. So just click apply, and you can see that we have our symbol here. For this one also, we can create our symbol. Just click on symbol here. And then for this one, also the upper part, fillet weld, and put the leg one here. So the leg, our leg is 2.8, and we don't have any intermittent, okay, the length and the pitch. Also, you can have the contour here. We have flat, concave, and convex. Okay, so let's see, for our fillet weld here, we want to communicate with our colleague. So this one, we type MIG weld. Okay, so that this is more like the info part where you can put your info here. And notice that this is, you can also click on link to fillet weld, where it will automatically link here, and instead of manually input your length or your leg one length, okay, so it will automatically detect from this welding here. Click apply, and then you can just pull this one here. So now you have your symbol. So that is on the manually created the symbol. Okay, thank you for asking, Mr. Hanan. You can automatically add the symbol, right? So let me just rotate it a little bit. We change this part here, right? So now I'm going to weld this one here. So we just use the fillet also. Okay, for this part, first phase and second phase. And we are going to use the flat also, right? And you will notice that we have this create welding symbol tick box here. So we can just click on this, okay? And then let's say this one is on top, okay? And we can link it to current bit, which is our current here. And if let's say we change to 3 or let's say 5, okay, you will notice that this number will also automatically updated. Thank you, SS Ong, for joining our free lesson. And for this part here, probably we are going to use, let's say, small rod size 10. Okay, and then just click apply, and you will automatically create this. Okay, just close this. Okay, now you will automatically create this symbol when you already finish create your weld bit, right? Does that answer your question, Mr. Hanan? Okay, so that we could communicate better with our weld technician or also the welders, right? Okay, you're welcome, Mr. Hanan. Right, so the next one, okay, as we know, we have a lot of types in welding, okay? So if let's say we want to show the weld in our model or our drawing, okay, but we don't want it to show it like this. We just want to make like a simple note there. So we can use the cosmetic. Let's say for this one, we are going to use the 3G, okay, the 3G welding, right? So select this part, and then you can create the welding symbol, okay? And for this one, you also want to use the fillet wheel. And let's say for this one, you just want to put the value here 2. And this one, you put it 3G, let's say Jetao or MIG, right? And for this one, you want to, the length is, let's say, the length for this plate is 28. So you want to make it like only from the bottom here. Okay, let's say 10. And for the intermittent or the for the pitch is 12. Okay, because we have 28 here, so we want another part to be up here. Okay, now, okay, you can also use the current bit, which is none, or we can just manually put it here. So the length is 10 and 12 here. And we want to make note here, this one we want to create a flat weld. So just click apply, and you will notice that we have this orange color here. So let me zoom in a little bit. So this orange color here. And also you have symbol for this one, right? So the cosmetic is more on you want to tell that for this part here, okay, between this T plate and also this metal vertical plate, okay, you want to make a 3G fillet here. Okay, so instead of you make like this, you can also use the cosmetic, right? And also you can, let's say you have a 5G or a cylinder, you can also use the cosmetic to that, right? And next, you notice that we have this hole here, okay? And I already opened the inventor part of this, right? And then I'm just going to delete this hole here, okay, and delete all the costume sketch. And when we go back to our assembly, let me save this. Okay, right. That's because we changed the environment to Weldment just now. Okay, it's supposed to automatically update in the normal assembly, or to make sure that you can automatically update. Let's say for this one, we just going back with the hole, and then just click on new assembly, just open directly the weldment. So this will make sure, okay, let's say we place this component, the plate here, home, okay, we place it, and then let's say we update this one, we delete the whole, right? And then in our assembly, weldment assembly, it will automatically update. So that's the difference between you open the assembly directly using the weldment, and also you open the standard assembly and then you convert to weldment assembly. Right. So next, we have our machining. Okay, we go back to our assembly here. So we have our machining here. So for machining here is we want to create, let's say we want to make changes after the weldment. You can, let's say, add holes here. Okay, for this part, maybe we want to, okay, 10 is too big, we put it 3, right? And then just select from this, we want to be 2, and also this one here is 2. So just click OK, and then it will create a hole for you. So this is machining. So machining is basically like 3D modeling or 3D editing, but this one here is you create post-process, which is you create features after you created the welding, instead of you created it. Okay, let's say in your model you already created it. So for this one, the machining, the difference is it is after, right? And also we have quite a few weld here, right? So we can just click on return. The next one here is we have the bits report. So when we click on this bit report and we tick on the include all the sub-assembly, right? It will create a report on your weld bits. So let's say weld bit report new, right? And then I am just going to open my Excel. So just browse. Okay, this one we have the report new here. Open. Right. Now, right, you can see your document, okay, because my document name is assembly, right? And it will type the identification for your weld. So it will tell you, okay, what type it is, fillet weld, okay, groove weld, and also the cosmetic. And also for this one, okay, because the first plate here, let me show you, okay, from this side here to here is 10 mm. So it will automatically update your length to 10. And also UOM is the unit of measurement. You also will get the mass of the weld bits so that you can make, let's say, calculation or simulation before you doing the weldment to your model. So that's why I say in our slide, okay, we can reduce the cost and also project what our end result will be. And also you can have the area for your fillet wheel, groove wheel, and also the volume. So because just right now we only have simple model. So what we have here is only a simple one. And if let's say you have a lot more complicated one, then your Excel will show all the sub-assembly. And let's say we save this, right, to this one here. Yes, to all. Oops, okay. And then next we have our weld calculator. So let's say for weld calculator, this one is we just want to calculate whether it is plausible if we want to create our welding. So let's say we have the field calculator, and then you can select your weld load. Either it is axial force, okay, going back and forth or going upwards and downwards, okay, you can change your weld load. And let's say for axial force, okay, for this one, the axial force is 2000 Newton. And our weld height, okay, let's say our weld height should be, and the weld length should be, let's say if we put like just now, 10 and 2. Okay. And then we can click on calculate. You can see that this one here show in red. And then what does it mean? That it show that the stress, okay, the 2000 Newton cannot be endure or cannot be bear by our weld dimension, which is 10 mm and 2 mm weld height. So for this one, you can try and error to see whether based on your force, okay, and also you can, okay, for this part you can make, let's say you want to make the weld bigger. Let's say our weld should be 100 and our weld height should be 15. And then we calculate, okay, now it does not show any of the stress, which means that our weld bit for the length of 100 and also weld height for 15 can bear the axial force of 2000 Newton. So this is the idea of the weld calculator in Inventor. You can also use the fatigue calculation. Okay, let's say for fatigue calculation, probably you need to choose the other. Okay, you also can calculate for butt weld. Okay, for let's say horizontal plate where you groove, and then you can calculate this one here. Okay, same as before, but based on the application. So for butt weld, okay, usually we will weld thing like this. So as you can see in our weld loads, so this is the type of load that the weld will bear. So you can either choose only one load, or you can also add multiple load that the weld will bear, and it will show you the result. Or you can use the comparative stress, and you can put the yield stress, safety factor, and so on. Right. So that is all the time that we have. And if let's say you have any question, you can just ask from the chat. I will put on the chat one more time for the data set, right? And while we wait, okay, so this is the Autodesk Product Design Manufacturing Collection, or PDMC, where, okay, where you can have what you will get is you will get the 3ds Max, Fusion 360, and also AutoCAD and Inventor. And for Inventor, we have Inventor Pro, okay, which what we are learning right now, and the Inventor Nastran. So for Nastran is used for simulation, right? And we have Inventor Tolerant Analysis. Okay, this is more for on the documentation and report. For CAM, okay, this one is more on the manufacturing tools, nesting, okay, and also the recap. Right. And this is the product that you will get if you are if you want to buy the Inventor. The price of sold product of Inventor is a lot more expensive than rather than you buy the product design manufacturing collection, because you get all these combined together in one collection. So if there is no question, I will end my free online lesson for today. And thank you, Ms. Chuin, Mr. Hanan Bahtin, Shahir Zuni, and also SS Ong for joining our free online lesson for today. And have a good day and stay safe.